Hi everybody, I know this is your first time seeing a video that I actually recorded, so this is my setup. You can see what I'm doing here, okay, and then you can see my face in the corner. Okay, so let's get started. We're going to talk about 4.2 exponential functions. If you haven't watched the 4.1 video, you really need to do that first. Okay, so go ahead, pause the video, go back and watch the 4.1 video, but let's get started. Okay, so the first thing I want to do is remind you of what makes something an exponential function. Okay, so an exponential function, okay, so they should all have the same format. Okay, so f of x or y is equal times a times b to the x. Okay, so remember a is the initial amount. Okay, and then b is the growth or decay rate. Okay. So what we're going to talk about first is how to graph exponential functions, and we're going to use the base graphs and transformations method. Okay, so let's look at some base graphs. Okay. Okay, so we're going to do this for two different types. Okay, so first we're going to look at the function f of x equals 2 to the x. Okay, and we're just going to plug in some x values. Okay, now our ultimate goal is to avoid plugging in x values, but for right now, we are going to plug some in because we need to develop what the base graph looks like. Okay, so we're going to plug in this x value, 2 to the negative 2, so remember that means 1 over 2 squared. Okay, so this is going to be 1/4. All right, 2 to the negative 1, this is going to be 1 over 2 to the first power, or 1/2. Okay, 2 to the 0 power, we know this is 1. Okay, 2 to the first power, this is 2. And 2 squared, this is 4. Okay, so we're going to go ahead and look at what those points would look like on a graph. Okay, so we're going to graph -2, 1/4. So we'll go to -2 and then we'll estimate 1/4. Okay, then -1, 1/2. So we'll go to -1 and estimate 1/2. We'll have 0, 1. Okay, we're going to have 1, 2. Okay, and then 2, 4. Okay, so you guys can see what those points look like, and we're going to connect those smoothly. Okay, so this would be one of our base graphs, the graph y equals 2 to the x. Okay, so you guys can see this is exponential growth, right? It's increasing as you go from left to right. Okay, so let's look at some decrease. Okay, so we're going to use the same values of x. Okay, but now we're going to look at a different function. Okay, there we go. We're going to look at 1/2 to the x. Okay, so remember, if this value of b is greater than 1, like in our first example, you're going to get growth. If the value of b is less than 1, like it is in this example, you're going to get decay. Okay, so we're going to, like I said, we're going to use the same values of x. Okay, and then we're going to plug them in. Okay, so I'll have 1/2 to the -2. Okay, so that negative exponent is going to flip my fraction. Okay, so this is 2 squared or 4. Okay, same thing is going to happen with the -1. Okay, we'll have 2 over 1 to the 1 power, which is just 2. 1/2 to the 0 power, that's 1. Okay, 1/2 to the 1 power, that's 1/2. Okay, and then 1/2 squared, that's 1/4. Okay, so now let's look at how those points would look on a graph. Okay, 1, 2, 4. Okay, so we're going to graph our first point, which is -2, 4. So -2, 4. Okay, then -1, 2. So -1, 2. 0, 1. 1, 1/2. And 2, 1/4. Okay, and then we're going to connect those smoothly. Okay. All right. So you can see when you look at these two, right, that the shape is mirrored. Okay. Similar in shape, but they're reflected. Okay. All right. So before we move on to talk about how we're going to graph these without just making a table of points, let's talk about some general properties of these graphs. Okay. Okay, now this is just properties of things of the form y equals b to the x, which are the base graphs. Okay, so the first thing, and you can see this from both of the graphs that we did, and you can also see it algebraically, is that the domain is everything, right? You are allowed to put any number you want into the exponent. Okay, we talked about having fractional exponents, we talked about having positive and negative exponents, so you could plug in any number to the exponent. Okay, so that means the domain, all values are allowed. Okay, now when you talk about the range, okay, if you have a positive number with an exponent, you're only going to get positive values back. Okay, now then you might wonder, okay, can you get 0 from this value? And you can't. Unless b is 0, which is not really an exponential function, you can't really get 0. So the range is only positive values and not including 0. Okay. All right. Then the next feature that's really important for the shape of the graph, okay, is the graph does not cross the x-axis. Okay, so much like you see with the 1 over x and 1 over x squared base graphs, you have that dotted line that keeps the graph from going below the axis. This graph has that same feature. Okay, and then the last thing that we're going to look at are the key points that we're going to use. Okay, so we're going to use the x values -1, okay, 0, and 1. Those are the key points that we use for most of the graphs if you're allowed to. Okay, so if you plug in -1, remember the negative exponent moves it into the denominator. Anything to the 0 power is 1. Okay, and if you plug in 1 in the exponent, you'll just have that base. Okay, So these are the 3 key points that we're going to use, and they'll be different depending on the different base. Okay? All right. So let's look at an example of how we're going to use this stuff to graph. Okay, so this time is the first time we're really going to use graphing using base graphs and transformations. Okay, so the first thing we're going to graph is just the base graph 4 to the x. Okay, so I'm going to use my key points. Okay, -1, 1/4. Okay, 0, 1. Okay, and then 1, 4. Okay, because in this example, b from these key points, right? B is the base, our b is 4. Okay, so now we're going to look at what my base graph would look like. Okay, so remember you have this dotted line on the x-axis. That's an important feature of the graph. Okay, and then we're going to plot our key points. So -1, 1/4, 0, 1, and 1, 4. Okay, and then we're going to draw in our shape. Okay, so that's how it would work to use these key points for a base graph. Okay, all right. Now let's look at some transformations of those graphs. Okay, now when I look at this, I can see that the base graph is the same as part A, okay, still 4 to the x, and this +1 is going to move my graph up 1. Okay, so I'm going to take my base graph and I'm going to move all of my key features up 1. Okay, so okay, so the first thing I'm going to draw in is this dotted line from my base graph. Okay, so I'm going to take my dotted line from my base graph and I'm going to move it up 1. So it's moving from 0 to 1. It's super important that you draw this in while you're graphing. Okay, then I'm going to take my first key point that was here at -1, 1/4. Okay, and I'm going to move it up 1 unit. Okay, then I'm going to take this point and move it up 1 unit. Okay, and then I'm going to take the point that was at 1, 4, and I'm going to move it up 1 unit. Okay, and I'm going to draw in my graph. Okay, now it's important that you have this dotted line to show that the graph doesn't go below this. It doesn't go down to the axis, it only goes down to this dotted line that's now at 1. Okay, all right. Let's look at another transformation using that same base graph. Okay. So the difference between B and C here is that in the previous one, the +1 was off to the side. Here, the +1 is in the exponent. So because it's inside the function, we know that it affects x, and this is going to move our graph left 1. Okay, so we're going to take our base graph 4 to the x, and we're going to move it left 1. Okay. All right. So our dotted line moves left 1, looks the same, okay? This point that was at -1 1/4 is going to move here to -2 1/4. This point from 0 1 is going to move to -1 1, and this point from 1 4 is going to move left to 0 4. Okay, and then I'm going to draw in the same shape as the base graph. Okay, so you can compare that to the original base graph. There it is. Okay, and here's our transformed graph. Okay, just left one. All right, let's look at one more base graph. Okay, so we're going to use a different base graph this time. Okay, so our base graph is going to be 1/3 to the x. Okay, so our key points, again, we're always going to use the same x values. Okay, so when you plug in -1, that's going to flip our fraction. Anything to the 0 power is 1. Okay, and to the 1 power is just the base. Okay, so those are our key points. Okay, so now we're going to graph those, and we're going to see what our graph looks like. So we're going to draw in our dotted line on the axis, okay? That's in all of the base graphs, and then we're going to draw our key points. Okay, so -1 3, 0 1, and 1 1/3. Okay, and then we're going to draw in the shape of our graph. Okay, now you can see this is exponential decay, right? The graph is getting smaller as you move from left to right. Okay, and that's because the base 1/3 is less than 1. Okay, all right. So now that we have our base graph, let's look at some transformations. That's my dog. Okay, so this, when you have the times 2 in the front, okay, it's outside the function, it's way out in the front, and when you multiply, remember that is going to stretch the graph. So this is going to stretch vertically times 2, okay? So we're going to take the y coordinates of all of our points and multiply them by 2. Okay, all right. So our first point was at -1 3. Okay, so the x coordinate, oh, we're going to draw in our horizontal line. Okay, that doesn't change at all because 0 times 2 is still 0. Okay, so we're going to take this one that was at -1 3. Okay, so 3 times 2 is 6. So the x coordinate exactly the same, -1. New y coordinate is doubled. It's at 6. Okay, then we're going to take the point that was at 0 1. X coordinate is still the same, 0. Y coordinate, 1 times 2 is 2. Okay, and then the last point was at 1 1/3. So the x coordinate is exactly the same. It's 1. 1/3 times 2 is 2/3. Okay, so our graph is going to look like, oops, this. Okay, so this would be -1 6, 0 2, and 1 2/3. Okay, x coordinates are exactly the same, the y-coordinates are multiplied by 2. Okay, and you can compare those to the original key points. All right, let's do another transformation of that graph. Okay, so we're going to do 1/3 to the negative x. Okay, so this negative sign is inside the function, right? It's an exponent, that's the function. So it's inside the function, so this is going to reflect it. Okay, negative signs always reflect. And because it's inside it affects x, it's going to be across the y-axis. Okay, all right. So let's look at our graph. Okay, so we're going to take our dotted line. Okay, when you reflect the dotted line, it doesn't look any different. Okay, we're going to keep the point that was at -1, 3. Okay, and we're going to reflect it across over here. Okay, and then the point that was at 0, 1, reflect it across. It's in exactly the same spot. Okay, the point that was here at 1, 1/3, we're going to reflect it across over here. Okay, and then we're going to draw in our graph. Okay, so if you compare this to our original graph, okay, there's our original graph, and there's our reflected graph. Okay. All right, so at this point during class time, I would ask you guys to do the worksheet that's assigned for 4.2. That is uploaded onto Canvas, and I will post the answers probably tomorrow. Okay, so let's talk about exponential equations. Okay, so for today, the technique that we're going to use is called equating exponents. Okay, we will talk about other techniques as we get further in the chapter, but right now, this is the technique that we're going to use to solve these. Okay, so let's look at an example. Oh, well, I guess I should tell you the idea of the technique first. Okay, you want to rewrite everything as a power of the same base. Okay. Then you want to use exponent rules to simplify. Okay. And then you are going to equate exponents. We'll see what that means. Okay. And then the last thing you're going to do is just finish solving normally, whatever that means for that problem. Okay. All right, so now that we've got a plan, let's look at our example. I have no idea what example number I'm on. Maybe 4? Yes. Okay. Okay. So you can tell it's an exponential equation because the variables are in the exponent. That's what makes something an exponential equation, okay? So what we're going to do now is pick a base that we think we can write 3 and 27 in terms of that same base, okay? So you want to pick something that you could write 3 as a power of that number and 27 as a power of that number, okay? So to me, it makes sense to use 3 because this is already written in terms of 3, right? And 27 could be rewritten in terms of 3, okay? So 27 is 3 cubed, so I'm just going to rewrite my 27 as 3 cubed, okay? This 1/2 power is this one, nothing changed there. Just rewrite 27 as 3 cubed. Okay, and now I'm going to use my exponent rules. When I have an exponent raised to another exponent, I know that I need to multiply them. So 3 times 1/2 is 3 halves. Okay. Now here's where it comes to actually equating the exponents, okay? So you have two expressions that have the same base, okay? So because the base is equal and the whole expression is equal, that means that the exponents must be equal. Okay, so this is what we mean by equating exponents. The two expressions are equal, they have the same base, then the exponents must be equal. Okay, and then I'm going to finish solving this problem by adding 1 to both sides. Okay. All right, let's try that same technique with a different example. Okay. Now again, we want to pick something that we could rewrite 27 in terms of that base, and we could rewrite 81 in terms of that base. Okay, so in this case, you can see they're both powers of 3, so I think that's our best bet. So we'll rewrite 27 as 3 cubed, and we'll rewrite 81 as 3 to the 4th. Okay, now we're going to use our basic exponent rules, 3 times this exponent. So I'm going to distribute to give me 12x plus 6. Okay, and I'm going to do the same thing here to give me 4x minus 4. Okay. All right. Now we're to the step where we need to actually equate our exponents. Okay. So we're going to set our two exponents equal to one another. Okay. And now we have a linear equation that we know how to solve. So I'm going to subtract 4x from both sides, subtract 6 from both sides, and divide. Okay, and then I'm going to reduce my fraction. All right. So let's look at a little bit more complicated example. Oh no, we'll do one more example like this, and then we'll move on to a more complicated example. Okay, so we want to pick a base that 8 could be rewritten as and 4 could be rewritten as. So to me, I think 2 is our best choice. Okay, so we would rewrite 8 as 2 cubed, and we would rewrite 4 as 2 squared. Okay, now we're going to multiply our exponents. 3 times x minus 1 is 3x minus 3. And we're going to multiply our exponents here. 2 times 2x plus 5 is 4x plus 10. Okay, so now we have a single term on each side, same base. We can equate our exponents. So 3x minus 3 equals 4x plus 10. Okay, and now we have a nice linear equation that we know how to solve. Subtract 3x from both sides, subtract 10 from both sides. Okay, and there's our answer. All right. So as promised, we're going to do a little bit more complicated example. The only way it can get more complicated is in terms of how hard it is to rewrite things with that base. Okay. Now, when I look at this, I can see that everything is a power of 2, right? The base here is already 2. Remember, this is a power of 2, and 16 is a power of 2. Okay, so I'm going to rewrite everything we have as a power of 2. Okay, so ask yourself now, what is the square root of 2 written with an exponent? What exponent is the same as square root? Okay, it should be the 1/2 power. Okay, and then 16 is 2 to the 4th power. All right, so now I'm going to simplify using my exponent rules. Okay, so when you have a fraction like this, the rule is that you would subtract the exponents. So 1/2 minus 4, right, is going to be negative 8 minus 1 is 7/2. Okay. All right. So now we have an equation that looks like any other equation, and we can equate our exponents. Okay. I'm going to add 1 to both sides. Okay. And then divide both sides by 2. That would be my final answer. Okay. All right. So that's all there is for this section. Okay, so I'm going to remind you guys to do the 4.2 worksheet and to work on the homework. You're submitting your homework through Canvas, so make sure you get that completed, and I will see you guys soon.